This video will discuss the probability of Polaris, the North Pole star. Astronomical objects can be thought of as points on a giant sphere called the celestial sphere. Earth is at the center of the sphere. The sphere spins relative to the Earth. Now, it's actually the Earth that is spinning, but it's often convenient to think of the sphere as the thing that's spinning. The rotation axis passes through the Earth through its poles. The sphere revolves once per day. All objects in the sphere make this rotation. But there is one easily visible star near the north rotation axis. This star is called Polaris because it is so close to the pole. A long exposure image shows where the pole is and which star is Polaris. As you can see, Polaris is a little white speck near the center of all these circles. Polaris is the 49th brightest star in the sky if the sun is included. It is a type of star whose brightness varies, but it is definitely in the top 100. I was curious how big of a coincidence Polaris is. So I decided to calculate the probability that one of the 100 brightest stars would be within 1 degree of the North Pole. I assume that each star is assigned a random point on the surface of the sphere. Thus, the probability that a star will fall on a specified part of the sphere is given by the area of the specified part over the area of the entire sphere. I am interested in a circle with radius 1 degree around the north rotation axis. The radius of this circle can be found in multiple ways, since 1 degree is so small. The curvature of the circle's surface is negligible. Let lowercase r denote the radius of the 1 degree circle, and uppercase R denote the radius of the sphere. Lowercase r is approximately equal to uppercase R tangent of 1 degree, which is approximately equal to uppercase R sine of 1 degree, which is approximately equal to uppercase R times pi divided by 180. Any of those 3 ways to calculate lowercase r gives you lowercase r is approximately equal to uppercase R times 0.01745. By generally accepted formulas, the area of the circle is pi lowercase r squared, and the area of the sphere is 4 pi uppercase R squared. So, for a random star, the probability that the star falls within the 1 degree circle is pi lowercase r squared over 4 pi uppercase R squared. Substituting for lowercase r, the probability is equal to that, which is equal to that by canceling pi and uppercase R squared. And then if we evaluate that, it is equal to 0.000076. So the probability that a random star is within 1 degree from the north celestial pole is 0.000076. But this is not representative of the probability of Polaris, because Polaris is not the brightest star in the sky. Let's find the probability that one of the top 100 stars will be within the 1 degree circle. For each star, the probability of not being in the 1 degree circle is 1 minus 0.000076, which is 0.999924. So the probability of all of 100 stars not being within the 1 degree circle is 0.999924 to the power of 100, which is 0.9924. So the probability that at least one of 100 stars will be within 1 degree of the north celestial pole is 1 minus 0.9924, which is 0.0076, or 0.76%. Only 0.76%? That's less than 1 in 100. The probability of having a better pole star than Polaris is not something that can be measured objectively, but it is very unlikely. Polaris is generally accepted as a coincidence. But there's more that you need to know about Polaris. The North Celestial Pole has not always pointed to Polaris. It moves in a circle in the celestial sphere with a period of 26,000 years. Here's a nice picture showing the precession of the North Pole. This picture uses the year numbering system we use for practical purposes. Thus, the current year is about 2000. That's where Polaris is. About 5,000 years ago, that was the year -3000, there was a nice pole star called Thuban. That was about the time the pyramids in Egypt were being built. The sixth brightest star in the sky is called Vega, and it's pretty close to the circle, but it's on the other side. The North Pole comes closest to Polaris in the year 2100, or 2100. It will be about 0.45 degrees from Polaris. Polaris is one of many natural coincidences. Another would be the quality of eclipses Earth gets from the moon. Let me explain that. The moon appears about the same size as the sun in our sky, by sheer coincidence. As a result of that, we get perfect eclipses, which no other planet in the solar system gets. What you believe about these natural coincidences is up to you. You might find that some of them are actually significant enough to believe that some kind of superhuman intelligence did them, such as aliens or a god. But you will, of course, be expected to follow naturalistic beliefs in school these days. That's all I have in this video. Thanks for watching.